can test our understanding. Okay, so we have a simple pendulum here. This is a simple pendulum, and we are having um, the fixed position where the simple pendulum is fixed, or where the simple pendulum is hanging from. So this is a simple pendulum. So as we can see, the bob is moving from point A to point B and back to point C. Okay, so the angle between the original position and the extension is called amplitude, and the distance between the fixed position and the bob is called length of the bob. So we have the simple pendulum here. Now let us define these factors found on the simple pendulum. So we are going to start with the oscillation. So what is oscillation? So oscillation is a complete swing from point A to point B to point C and back to point A. So oscillation is a complete swing. Oscillation is a complete swing. Period. So what is period? So period is the time taken for the pendulum to make a complete oscillation or to make a complete swing. Time period is the time taken for a pendulum to make a complete oscillation. Amplitude. What is an amplitude? Amplitude is the distance between the rest position of the bob to the extreme end of oscillation. Okay, amplitude, or we can say amplitude, is the angle formed between the rest position of the bob and the extension. Okay, so the first thing that we are going to do is to look at the factors that affect the period of the pendulum. So the first factor that we are going to look at the length. So the longer the length, the longer the period it will take to make a complete oscillation. So we have seen that the length of the pendulum affect the period of the simple pendulum. So length is one of the factors that affect the length of the simple pendulum. Acceleration due to gravity also affects the period of the pendulum. Acceleration due to gravity also affects the period of the pendulum. Amplitude also affects the period of the pendulum. Let us also look at factors that does not affect the period of the pendulum. So number one, mass does not affect the period of the pendulum. So the period of the pendulum is independent of the mass. By the way, the force of gravity is direct proportional to mass. So therefore, mass does not affect the period of the pendulum. Air resistance is negligible. Resistance does not affect the period of the pendulum. Let us look at the steps that we can follow to find the period of oscillation. So the first thing that we need to do is to take the total time for total number of oscillation. We need to take total time for a total number of oscillation. Then number two, we need to repeat step one. Step number three, we need to take the average of the trials the total number of oscillation. We need to take the total number, the average of the total number of oscillation. Then the fourth step, we need to divide the average in step 3 by the total number of oscillation. So we need to take the average of the total time for total number of oscillation. Then after that, we need to divide that average by total number of oscillation or total number of swings. So the average we are talking about here, we are talking about time. So we need to divide time by number of oscillation. We need to divide time by number of oscillation. So we have a question here, and this question is coming from 2020 past paper, and this paper is paper 1. And the question is question B1. Figure B1.1 below shows a simple pendulum suspended from a fixed point. The bob is slightly pulled to position A and then released. Question A, state one factor that does not affect the period of the pendulum. So we are from discussing the factors that does not affect the period of the pendulum. So one of the factors that does not affect this, the period of the simple pendulum is mass of the pendulum bob, or mass of the bob. So the mass of the bob does not affect the period of the simple pendulum. Air resistance also does not affect the period of the pendulum. Without wasting much of our time, let us move to the next question, which is question B. If the values of time for 20 oscillations obtained were 16.1 seconds, 15.9 seconds, 16.0 seconds, 16.2 seconds, and 15.8 seconds, calculate the period of the pendulum. So to find the period of the pendulum, we are going to find the average of the times given. So as we can see, the experiment was repeated several times, as evidenced by the number of times given here. So we are going to find the average of the time given. So the first thing that we are going to do, let us bring the formula. We are going to say period is equal to time over number of complete oscillation, or number of complete swings. So let us find the average of the time given here. So we are going to say 16.1 plus 15.9 plus 16.0 plus 16.2 plus 15.8 divided by 5. We are going to get 8 divided by 5. So 8 divided by 5, we are going to get 16. So the average time that we have is 16 seconds. The number of complete oscillations is 20, as given here. The number of complete oscillation is 20. Let us come up with data so that you can see properly what we are talking about. So the time is 16 seconds. Then the number of oscillation is 20 oscillation, or 20 swings. Now let us plug these values into our formula. So we are going to say period is equal to 16 divided by 20. So 16 divided by 20, we are going to get 0.80 seconds. So 0.8 seconds is our 0.8 seconds is our period. So as we can see, we have successfully managed to find the period of the pendulum. Let us move to the next question, which is question C. Question C reads, calculate the frequency of the pendulum. Calculate the frequency of the pendulum. So there are a lot of formulas that we can use to find frequency. So one of the formulas, since we are from calculating the period of the pendulum, so this is the suitable formula that we are going to use. We are going to say frequency is equal to 1 divided by period. So capital letter T stands for period. Okay. So we are going to say frequency is equal to 1 divided by, we are from calculating period, which is 0.8. So 1 divided by 0.8, we are going to get 1.25 Hz. By the way, frequency is measured in Hz. So our answer therefore is 1.25 Hz. So as we can see, we are done with this question. Let us move to the next question. So this question is coming from 2010 past paper, and the question is question 2. Figure 2.1 shows a simple pendulum that oscillates between position A and C. It takes 2.05 seconds to go from A to C and back to midpoint B. Question A, Roman numeral 1. Calculate the period of the pendulum. Calculate the period of the pendulum. So the first thing that we are going to do is to come up with the formula. We are going to say period is equal to time over number of complete oscillation or number of complete swings. Let us collect data. So the time we are given, the time it is taken to do this oscillation is 2.05 seconds. Then the number of oscillation. Here, let us pay attention so that we understand. So 4 quarters make one complete oscillation. 4 quarters make one complete oscillation. So as we can see here, we have 3 quarters instead of having 4 quarters. So therefore this one will not make a complete oscillation. So we are going to make a fraction here. We are going to say 3 out of 4 quarters. So to make a complete oscillation, we need 4 quarters. But here we have 3 quarters. So we are going to say 3 out of 4 quarters. So 3 out of 4 quarters, we are going to get 0.75 oscillation. So the number of oscillation is 0.75 swings. So therefore, we are going to say 2.05 divided by 0.75. We are going to get 2.73 seconds. So as you can see, we have found the period of the pendulum. We have found the period of the pendulum. Without wasting time, let us move to the next question. Calculate the frequency of the pendulum. Okay, so like I said, there are a lot of formulas that we can use to find frequency. So the best formula that we are going to use here is this one. We are going to say frequency is equal to 1 divided by period. Frequency is equal to 1 divided by period. So frequency is equal to 1 divided by period, which is 2.73. We are going to get 0.36630. So the frequency of this pendulum is 0. By the way, we have rounded off this number, and our frequency is 0.37 Hz. Okay, let us move to the next question, which is question B. Briefly describe how the period of a pendulum would be measured. So here they want us to devise, or they want us to come up with the steps how we can find the period of a simple pendulum. So these are steps. These are steps that we need to follow. Take the total time for total number of oscillation. Repeat step 1. Take the average of the trials. Divide the average in step 3 by total number of oscillation. So these are steps that we can take to find the period of a simple pendulum. We are also going to answer this question, which is coming from 2013 past paper, and this paper is paper 1. The question is question 1. The diagram below represents a pendulum. The length of the pendulum is okay. The length of the pendulum is 10. The length of the pendulum is 10. Not 2. I made the mistake here. Our answer is 10. We move to the next question. This question is coming from 2019 paper 1. And the question is question A2. The diagram below shows a bob of a simple pendulum that swings from position A to position B. If it takes the bob 0.5 seconds to swing from A to B, what is the period of the pendulum? What is the period of the pendulum? Okay. So to find the period of the pendulum, we are going to come up with the formula. Period of the pendulum is equal to time over number of swing or oscillation. So time has been given, which is 0.5 seconds. So the time is 0.5 seconds. Then the number of oscillation, remember I said 4 quarters make 1 complete oscillation. As we can see here, we have been given 1 quarter. So we are going to come up with a fraction. We are going to say 1 out of 4. The number of oscillation is equal to 1 out of 4, which is 0.25 oscillations or swings. Now let us come up with the period. So we are going to say period is equal to 0.5, the number, the time taken, 0.5 divided by 0.25. So period is equal to 2.0 seconds. So therefore our correct answer here is A. Our correct answer is A. So as we can see, we are done with this question. Let us move to the next question. We move to the next question, and this is our last question. So this question is coming from 2024 paper 1 GCE, and the question is question A1. The diagram shows a simple pendulum that swings from A to C and back to B in 0.75 seconds. What is the period of oscillation? What is the period of oscillation? So here we are also going to begin by applying the formula. We are going to say period is equal to time over number of oscillation. Then let us collect data. What have we been given according to our question? So we are given time, which is 0.75 seconds. Then the number of oscillation, remember I said 4 quarters make 1 complete oscillation or make 1 complete swing. So as we can see, instead of having 4 quarters here, we have 3 quarters. So we are going to say 3 divided by 4. 3 divided by 4, the number of oscillation is equal to 3 divided by 4, which is 0.75 oscillations. or swings. So therefore, we are going to say 0.75 divided by 0.75 is equal to 1. So the number of oscillation, the period is equal to 1 seconds. So therefore, our correct answer is C. Our correct answer is C. So this brings us to the end of this video.